The graph of y is equal to the first derivative of f of x, where f is a cubic function, is sketched below. So we have a parabola function there with the x-intercepts as -4 and 1. We don't know more about the y-intercept. And then now, guys, it means at first we had this graph, this function, f of x is equal to ax cubed plus bx squared plus cx plus d, where d is the y-intercept. So this is a cubic function. So when we differentiate this cubic function once, we get what? We get a parabola function, right? So we differentiate. We say 3 times a, we get 3a, and then we subtract 1, we get x squared. And then we say 2 times b, we get 2b, and then we subtract 1, we are left with x. And then 1 times c is 1, is c actually, and then 1 minus 1 is 0, so x to the power of 0 is 1, times c is just c. So this one is a constant, so the derivative of a constant number is it's 0. So when we differentiate a cubic function, we get a parabola function. And then you have to know that the x coordinates of the turning points of a cubic function, after differentiation, they become the x-intercept of a parabola function, right? The point of inflection, the x-coordinate of point of inflection of a cubic function becomes the x-coordinate of the turning point of the parabola function. So for which values of x is the graph of y is equal to the first derivative of f of x decreasing? So we have to work out this, which we call it the axis of symmetry, or the x-coordinate of the turning point of a parabola function. So we are going to say x is equal to, we say -4 plus 1 divided by 2. The reason we do that is because the axis of symmetry is the vertical dotted line that divides the parabola graph into 2 equal parts. So it means we get what? We get -3 divided by 2. So it means when we move from this part upward, that's where the graph is increasing, and then on the right hand side of the turning point, the graph is decreasing. So it means x is greater than -3 divided by 2, and then we get 1 mark.